I think the first thing is thanks to Sig. He came to us a little while ago and struck up a working relationship with us. And I invited us over here to share some of my thoughts and experiences around electric vehicles. My name's Eliot Smith. I work, well actually, I don't like to say this, but I actually own the company. But I don't like saying it, I don't know why. But we run a company called Promoto Europe in the UK. And we've been running for about 15 years now. Okay, so we established it about 15 years ago, more around about electric vehicle technology, because of my previous history. My previous career was with mainly working with Honda UK and Honda Europe. Okay, so I'll explain a little bit more about my background in a second. So what I thought I would do is explain, share you my experiences and the challenges that we see in the UK in the automotive industry as we start to see, we're seeing electric vehicles of different types being established in the marketplace, of which in Iceland you're starting to see that now. So when was the first time you saw an electric vehicle in Iceland? And do you know what it was? Okay, 20...
But individual cars maybe before that?
Some 10 years ago.
Yeah.
About that.
That's a common.
That's a long time.
Sure, okay.
15 years ago.
And very small numbers, yeah?
Yeah.
Yeah. So you...
Maybe 20 years ago, because we had first, on 76 volts or something like that. Okay. With a gearbox and everything.
Sure, yeah. There's all sorts of types. Okay. So I worked with Honda Europe and then obviously established myself as an independent training provider. We don't get funding from anybody else unless we see clients come to us for training purposes. We don't get any funding anywhere else, so we're completely independent, which means we have to be fairly agile to what our clients' requirements are. To give you some idea, we might be working with fire crews, for example, because they need to attend road traffic accidents. We might see police investigation people that need to investigate why the accident happens. They're going to work on these types of vehicles. From there, we will look at training independent garages, individuals from those garages, or even larger motor groups where they got many dozens of people or technicians in workshops that are starting to see these types of vehicles come through their workshops more and more. From there, we work with manufacturers. So one of the biggest challenges for manufacturers is how do you get 2,000 or 3,000 staff who are assembling normal, conventional production vehicles to start to assemble electric vehicles, including the battery assembly and so forth and so forth. So there's a massive set of skill differences that are required for those type of disciplines within that organisation. And then we work with people that are actually designing and developing new technologies or new applications of technology into electric vehicles. And then we work with things like universities where we're looking at perhaps development of different types of batteries, configuration of batteries, and so forth and so forth. So there's a fair, broad experience that we bring to the individual of what our experience is in the automotive industry, not just for the independent garages, but for the challenges that the whole industry has as far as producing, maintaining, and disposing of these types of vehicles, because there's a lot of influences in society that perhaps don't agree with the EV transition. They would say there's political reasons, there's environmental reasons, there's cost reasons, and most people don't like change anyway. I like change. I don't know about you guys, but I quite like it. Anyway. Here's a brief kind of outline of what I want to talk about. I'm going to talk about the history of electric vehicles briefly, because I think it's interesting to see where we came from and where we're at. We're going to look at the modern powertrain system, what major components take up or make up an electric vehicle system. Now, I don't mind And I quite often say this to a group of people is that if most of you guys work on vehicles, yeah, would I say that? Yes or no? Maybe some of you are nodding, okay? And the principle applies pretty much to every vehicle we work on a combustion engine. We have a piston, we have a camshaft, a crankshaft, a gearbox and a drivetrain system. Well, we can apply that principle that we've learned to pretty much any vehicle that comes through our workplace. Would you agree with that? Yeah. Yeah, pretty much. It's the same for electric vehicles. Once we have the principle in place, we can apply those principles to any type of vehicle that's electrified, whether it's a small passenger car to a heavy goods vehicle. It makes no difference. The principles are exactly the same, which is good because there's many a time I've been asked to look at a client's development of a powertrain system, and I've always kind of had some anxiety, some worry to say, well, what if it's different? What if I don't know what I'm talking about? And when you look round, it's the same. And I have this phrase, and I mentioned it in the meeting earlier, it's the same but different. Is that okay, guys? So I'm just going to cover off. And if you've got any questions about any things that I'm going to point out to you, please raise your hand. Or if you want to leave it to the end, we'll have a session of questions and answers then. We'll look at some alternatives to electric vehicles, see if there's a lot of debate as to what may be the alternative to the electrified powertrain system or the electrical power system that we see on most electric vehicles at the moment. And then I'm going to get a little bit sort of like, as far as we're concerned, what are the risks and dangers in the workplace as far as these types of technologies are concerned? Because they can be quite serious in some cases. Once we understand that, look at the transition, the challenges to EV as far as our industry is concerned. And I'm going to give you, if we've got time, an example that we came across a couple of years ago where a garage was trying to repair a vehicle. And I think I'm going to drill down a little bit of detail in how we got to the bottom of solving that problem, if you're interested. Okay? And of course, finally, how does it impact our lives as far as our society is concerned? Now, Iceland's probably a little bit different from the UK. And it's interesting, when you look at a lot of different countries, we're all along that kind of transition, but in different stages. Some countries are starting their journey. Some countries are well established in that journey. If you take Nordic countries, Sweden, Norway, so forth, they're pretty much down that line, quite advanced. Whereas you take the UK, we're about the middle. And if you take some sort of like Middle Eastern countries, we've got plenty of oil, don't worry. We're gonna manage it out ourselves. So, but the transition is still the same. Okay, cool. So, we look at a brief history. When do we start seeing the first electric vehicles?
Around 1900.
Yeah. Who made the first? Well, who's established one of the first electric vehicles in the automotive industry?
Wasn't it Ford?
Who? Sorry. Ford.
Yeah.
No.
They came up with the electrical vehicle in the 1900s.
The
Yes, they
first
did.
4x4 was Porsche.
Yeah.
Yeah, this first
Electric vehicle.
4x4.
Yeah.
Electric vehicle.
Yeah.
And you know, they produced. If you look at the specifications of these types of electric vehicles, this was first introduced in 1893. So we're over 100 years ago. Ferdinand Porsche developed a four-wheel drive, in-wheel electric motor for his development. And there, yes, Ford, some other companies also established some early electric vehicles. But what happened then? Why do we not continue doing electric vehicles?
They invented a better mode of transportation.
Yeah.
Combustion engine.
Someone started digging up oil out of the ground and decided how we're going to sell this stuff.
Yeah.
So I don't like to say this, but well, I will say it. I do like saying it. It's the Americans, wasn't it? They say, no, we've got a product. How are we going to sell it? We're going to sell it. We're going to refine it, and we're going to invent the combustion engine. So we spent over 100 years burning fossil fuels. It was perfectly fine for most of the journey. Did its job. created a lot of industry, a lot of jobs and stuff like this. But now we've come back to, well, when do we see the first modern electric powertrain system vehicle in certainly in Europe anyway? I know Iceland, you're part of Europe, aren't you? Yeah. When did we see the first commercially built modern powertrain system? And by the way, these manufacturers nailed it right from the start.
Prius, around 99.
Yeah, 1997. Oh, sorry, where did we go? 1997. Look at that beautiful looking car. And the question is, and I ask the question quite often, is that why do we make them so ugly? I don't know. Because look, the modern mobile phone, sexy bit of kit that, I quite like that, it's quite attractive and stuff like this, and everybody bought into this stuff, but we made, for whatever reason, we made these things really ugly. If someone had that in your neighbourhood, you'd know about it, wouldn't you?
Well, that's the reason.
Well, maybe, is it the reason? I don't know. Because you wanted to stand out.
To stand out.
Yeah, maybe so. The geeky type of, most people that started, the first people that bought Teslas were the geeky type of people, weren't they? Yeah. It's got lots of gadgets and it's different and everything else. And we spent a long time, and pretty much Toyota and Honda Motor Company developed the modern powertrain system, which is pretty much the same as it is today. And that's what, how many years ago? That's 27, 28 years ago. And we've seen a development from hybrid through to the modern powertrain system. So if we look at, if my works, the first Priuses, the first hybrids, these are complicated cars, guys, or powertrain systems, because we had to find a way to integrate the combustion engine in with an electric powertrain system and seamlessly transition between the two without any kind of interruption to the driving experience, which is really difficult to do. And there is a number of platforms that were developed. Toyota came up with what we call the power split system. To give you a little idea of how complicated it was, I was working on a project about 3 or 4 years ago, and I mentioned my project that I was working on to a couple of McLaren engineers. And these guys were independent consultant engineers. And they said, we can help you. We know what we're doing. We do the kind of data analysts and stuff like this. And I said, okay, fine. Come over to my workshop, have a look at a Prius and just download some data from it and tell me what you think, whether you can help me or not. And these guys came from Sweden, weirdly enough. I didn't know. They actually flew over from Sweden for the day. I left them with the car for an hour, and they downloaded this data, and I left them for about an hour, and I thought, well, it's a bit strange. It's taken a while for them to work it out, sort of thing, because these guys should be quite switched on. And I went back to them, how you going? And he says, we've never seen so much data come out of a vehicle as complicated as this. And if you look at the McLaren, like the P1, their hybrid, first hybrid, it's a very simple car. These are very complicated cars. Technology-wise, how they pulled it off, I don't know. But pretty much the same technology used on this early hybrid is used on every subsequent type of electric vehicle since then. And the hybrid was the introduction of the electric powertrain system. These cars could drive electrically, they could drive mechanically from the combustion engine, and the transition between the two seemed seamless. Really interesting technology. It takes a while to get your head around it. Once you have it, it's really, really interesting how they got around those sort of challenges. And of course, for most consumers of vehicles, when we're quite demanding about our vehicle, aren't we? We want it to be perfect. If we look at, I don't understand this sometimes, if we look at the modern automotive vehicle, we drive to work, it has central locking, yeah? Most cars do, they have electric windows, they have a climate system that keeps us nice and warm, or cold or whatever it is and stuff like this. And when we're driving at 60, 70 miles an hour, there's very barely any wind noise on that vehicle. Now look at your house. Do you have central locking? Do you have electric windows? Do you have a climate system? You may do. Does it, when the wind blows, there's probably wind that gets in your house at some point and stuff like this, but we have such high expectations of vehicles. And it takes a lot to pull this sort of stuff off. So the hybrid vehicle, when it was first came out, was a complicated car. Then we got into some plug-in hybrids. So now we had to develop technology where we could separately charge the battery up as opposed to allow the combustion engine to charge the battery up, or regenerative braking. Because don't forget, an electric motor is not just an electric motor, it's a generator as well. It does two things, which is quite good. The principle is exactly the same. But we had to find a way of what's the standards for plugging in? How were we going to connect it to just a wall socket, or we're going to have something specific to charge it in? And what protocols will they be able to manage to make sure that everything's safe while we charge that? Because we don't want to overcharge a battery, we don't want to undercharge a battery. And of course, we want to charge it as quickly as we can, and these sort of challenges as well. So a plug-in started to say, right, there's a challenge to the automotive industry. How are we going to standardize the charging for the vehicle? Does the car charge the battery, or do we have an external charger that manages charging the battery? And we have two methods. Okay, AC charging is dealt by the vehicle, DC charging is dealt by the charger itself. So there's some other challenges to understand there as well. And of course, then we got into things like range extenders. Come across these guys? Okay, so these are electric vehicles, but they have a combustion engine still. But the combustion engine never drives the vehicle. It's just there to drive the generator. So we can extend the range of the battery. So these things provided solutions for people to engage and start to lessen their anxiety into purchasing these types of vehicles. And of course, finally, we've got the full electric vehicle, which is pretty much the first one we saw. Again, a good looking car. I don't know why they always made them ugly. I don't get it. Full electric vehicle. And I guess the early ones were limited range, 24 kilowatt battery, not very far. Then they doubled it and they got it better and better and better and sort of thing. So we've got a reasonable range. What sort of ranges we get out of electric vehicles nowadays, guys? What sort of acceptable range? In kilometres. I guess you deal with kilometres here, don't you? Yeah. So what sort of ranges are we talking about now as an acceptable range?
300 to 400.
Yeah. That's enough, isn't it? Yeah, it's fine. Okay, cool. All right, so let's have a look at the modern powertrain system. First of all, we need a high voltage battery. What sort of voltages are we dealing with on these types of vehicles? Range of voltages. Say again?
800.
Yeah, why?
380, 360 to 800.
Yeah. So why are we going to 800? What's the advantage?
Ask them.
For capacity of the battery and the wirings.
Say again, sorry?
For capacity of the battery and the wirings.
Voltage doesn't increase battery
Yeah,
capacity.
but it seems to be better for charging also.
Why is it simpler?
More power, less current.
Yeah.
Yeah, we double the voltage, we divide the current, so we can have smaller wires.
Yes.
It's cheaper, if I'm honest.
For wirings.
Yeah, so the manufacturer increased the voltage because they haven't got to spend so much money on the cabling. And of course, if you go voltage, then you can actually charge quicker as well. So there's two advantages to it, sort of thing. But of course, when we talk about 800 volts, that's a lot of energy, isn't it? That's a lot of potential there. And of course, it's DC as well. Ask any electrician to work on a DC installation, and you'll get some let's say some words that you probably won't like. But yeah, DC installations are quite difficult. Of course, a substantial part of the vehicle system, and we need a battery management system for this, don't we? We need to maintain its state of charge. We need to make sure it's not overcharged, it's not undercharged, the balance in the battery, individual cells. So how many cells do you think we're going to get out of an average battery? How many cells would you think would be there? 90, yeah, something like that, possibly more. How many cells in a Tesla battery?
1,000.
How many?
1,000.
No.
Not cells.
Keep going.
Yeah. It depends on who.
7,000, yeah. So the configuration of batteries changes from manufacturer, and there are advantages to it, disadvantages. And imagine every cell in series is monitored. So you have a battery management system that's going to look at every individual cell in series, that's the voltages, to ensure the battery's in good condition. Any one of those cells fails, then we could be in trouble. And that's the challenge from a technician's point of view, is to identify any forthcoming problems with the battery, diagnose it, and possibly repair it. Because it's a bit like an engine. If you look at an engine and one of the cylinders gets weak, it puts stresses on the crankshaft, doesn't it? It doesn't like it. So we need to diagnose which cylinder that is. It's the same as batteries, guys. But then we're dealing with high voltages. Never forget, a battery is always live. Okay, it's never 0 volts. Okay, so there's always a potential when working on batteries. Okay, let's look at some other things. We need an onboard charger. And the onboard charger is going to obviously connect to a charger at some point, or your 3-pin or your wall socket, and it needs to manage that charging of that battery. It needs to understand and communicate with the battery management system to make sure that it's not going to overcharge it. When it's fully charged, it switches off. Okay, make sure that the battery management system will accept the charge. Is the temperature okay? It may preheat the battery. Particularly in Iceland, I guess you have some preheating that's going to be establish it, because batteries are a bit like us, you know. We're grumpy when we're too cold. We're grumpy when we're too hot. Okay, it's true, isn't it? Yeah. And batteries are the same. There's an optimum temperature where they will accept a charge and discharge much better and perform much better. So heating of the battery has to be established in some cases, or cooling. I wouldn't imagine that happens very often in Iceland, but if you go to the Middle East or some hotter countries, actually the battery will get too hot if we start to charge it. So the onboard charger has to do a number of things. It has to establish a connection with whatever you're connecting it with. It needs to convert whatever it's being charged from, that's the AC from the national grid, to DC. It needs to charge it at the correct voltage and to make sure it doesn't damage that battery. And of course, if you connect to a DC charger, then the whole thing changes. So we don't need to convert AC to DC. We need to directly charge the battery from the charge point itself. But again, we need to establish what voltage that's going to be, how much current it's going to be, and is the battery happy? And when it's fully charged, we switch it all off. So then it's safer. So that's your onboard charger. What else we got? DC-DC converter. What's that for, guys? Any ideas? No? You would know, hopefully. Do you know yet? Yeah. DC-DC converter. Look, most conventional vehicles have an alternator on them, don't they? Charges the 12-volt system.
We're going down from the high voltage to a 12-volt system, and we are also boosting up for the engine, for the motor.
No, it doesn't do that. The DC-DC.
No, the inverter does that. No?
Yes, the inverter converter, we'll come to that bit later on. But the DC-DC converter is your alternator on your vehicle now. It's connected to the high voltage battery. So whenever the vehicle's live or ready to drive, this now is your alternator. This is going to maintain your 12-volt system. Effectively, you've got two electrical systems on your vehicle. Your 12-volt system, which traditionally we use the vehicle body as our negative side of the battery. And we've got a high voltage system which is completely insulated from your 12-volt system.
But nowadays you have various voltages with the convenient system in your car, like Tesla. They had 16 volts now, not 12 volts.
Yeah, I mean, it doesn't matter what voltage it is, but it's not high voltage.
Yeah.
It's
for the battery.
The auxiliary system,
yes,
yeah.
Auxiliary system.
So for your lighting, your heating, your audio system, wipers, electric windows, communication systems, all going to be delivered from this.
And Tesla, do they use then 16 volt radio?
I mean, there will be a voltage range that they accept, certainly, but Tesla use a lithium-ion auxiliary battery, so it's probably fixed at 16 volts. So that's probably the charging voltage, but its nominal voltage is probably less, I would imagine.
But if you wanted to sell spare parts?
to a Tesla owner. Yeah. Fine, yeah. But yeah, the DC-DC converters, they're really to maintain the 12-volt system because you haven't got an alternator. There's no mechanical moving parts apart from the actual drive motor itself. So the DC-DC converter, if this fails, you're going to lose your 12-volt system. And remember, your 12-volt system controls your high-voltage system. So if this fails and your battery fails, or your 12-volt battery fails, you can't drive the car. Simple as that. So you've got to solve the problem. Cool, excellent. Right, now we're talking about inverter-converter. What does this do, guys? This is probably one of the hardest working components on the vehicle system. What does this do, guys? Any ideas? Most manufacturers, or most people refer it to as just an inverter, which I always say is incorrect. Inversion means that we take DC and invert it to AC, okay? So we take the direct current from the battery and we convert it to AC. And that drives our electric motor. Our electric motor is driven by, is principally a three-phase, asynchronous, alternating current, brushless motor, okay? So we have to change the DC to AC. You're probably thinking, well, why change it to AC? Surely that's just inefficiency. But an electric motor is far more efficient when it's driven by AC and certainly more powerful if it's a three-phase motor as well. So the inverter has to change the battery, DC stored into it, to AC and three phases. Okay? It has to understand the position of the electric motor very, very accurately to make sure that we commutate or phase those three phases in the right direction, okay, in the right sequence, and we deliver enough current and speed to give us the drivability of that electric motor. What happens to the electric motor when we back off the accelerator pedal? What does it do then?
You regenerate the power for sure, and then you have to do the other way around.
Yeah.
Otherwise it doesn't work.
No. Well, it's what I call Fleming's left-hand and right-hand rule, which means that if we use the mechanical movement of magnetic field against a piece of wire, we generate electrical current. So whenever the motor is not a motor, it's a generator. So, but of course, because it's a three-phase motor, it's going to generate alternating current. We can't put alternating current in a battery. We've got to now convert it back to DC. We've got to do it instantly. As soon as we lift off the accelerator pedal, that inverter no longer is drawing from the battery. It's now going to be putting energy back into the battery so we can regenerate that energy, that kinetic energy that we traditionally wasted. Because what did we do before? We just made more heat, didn't we?
Yes.
And we just let the atmosphere deal with that one, okay? Always amazed me. I mean, how efficient is a combustion engine given the amount of energy in a, say, a litre of fuel? How much energy do we actually use out of that to drive the vehicle?
35%.
Well done. You've done your maths. So that means that another 65% we pretty much waste in heat and mechanical losses, don't we? How efficient is a battery?
Battery?
Yeah, how efficient is a
I
battery?
don't know about the battery, but if you use a battery and to drive a motor, then it's about 90%.
Yeah, it's getting to, it's the upper end. A battery is about 99.99999% efficient because what we put into it, we pretty much get out of it every time. This guy will know because every time you use a battery, it diminishes its capacity every time that you charge and discharge it up. But we can manage that, that's not a problem. And it takes years and years and years for us to degrade a battery. But that's no different to degrading the condition of a combustion engine, is it really? Okay. So this inverter-converter has to deal with AC and DC and deal with it very quickly. And it also has to commutate or sequence the electric motor in the right direction, knowing what the driver wants to do with the vehicle. We can vary the speed, we can vary the torque anywhere we like. And that's the advantage. One of the reasons why it's more efficient is that if you look at a combustion engine, you'll drive cars, yeah, or motorbikes or whatever it is and stuff like this. There's always an optimum RPM range of that engine, isn't there? So normally when we change gear and, you know, if we go any higher, it doesn't feel like it's quite as good. If we go any lower, it struggles a little bit and everything else. And we've developed a gearbox to enable us to optimize that position where that RPM of that engine. Okay, so we've now went from 4-speed. If anybody, who drives I had a 4-speed car, I'm sure, I'm not saying, despite my youthful looks, 4-speed car, we went to 5-speed, then we went to 6-speed. And what we're trying to do is optimize that RPM range to get the more efficiency out of the combustion engine. The good thing about electric motors is that we can run them at any speed and any torque we like, and they're just as efficient whatever speed we run them at and whatever torque. So we can develop torque at 0 RPM, okay, and we can have it running at maximum RPM with 0 torque if you want. The inverter converter, in reality, is your gearbox, because it can vary the torque and increase the speed or decrease the speed and increase the torque wherever it likes. So that's where your efficiency comes from. Interesting stuff this is. Okay. PTC heater. Anybody understand what PTC stands for? No. No.
Temperature coefficient.
Coefficient. Yes. So as temperature goes up, so does resistance, doesn't it? Yeah? Okay, thank you. Okay. So the PTC heater there is there to heat the cabin and or the battery. But it's an electrical heater. It's like a heat exchanger now. We need one of these on there because there is no significant heat developed from the motor, the battery, or the inverter converter to deal with the temperature, the climate that we expect to get out of the vehicle. So we have to now have an electrical heater on board because we have no engine that develops a lot of heat. Thankfully, we're not wasting. So this is the reason why they're more efficient, because we've been smarter about how we use our energy, which is the conversations we had earlier about being smart about how we use and waste our energy. Finally, secondly, AC compressor. Now we need heat on some cases, because obviously we do on a cold winter's morning, but on some cases we need to cool it down and dehumidify the cabin as well. And we're so used to having air conditioning on our vehicles. Back in the day when I started my career in the automotive industry, some people might nod now, is you saw that blue button on the dash and people, what's that for? Oh, don't touch that, it's expensive, you know, and it never works, by the way, okay? But nowadays, air conditioning is on as a default, isn't it? It's a climate controlled system now in most modern vehicles. And we expect to have a dehumidified, nice dry air in our vehicle, and we can cool it down on a hot summer's day if we ever get one. How warm do we get here occasionally?
We've had summers that have been 3 days, 20 degrees.
Really?
Yeah.
Okay. Scorchio, as they say. So this is driven by electricity. So this is directly connected. And by the way, all of these components, whenever we're in the ready mode or when we switch the vehicle on, are directly connected to the battery. When that's switched on, everything is live. Okay? And there's a lot of potential there for things to go wrong. Just to give you a little idea, the air conditioning compressor has to run on a non-conductive refrigerant oil, because the motor runs in the refrigerant. If we put ordinary refrigerant oil in there, you'll get what we call a breach of insulation. And if you get a breach of insulation on this will switch off. You've got a non-start or a breakdown situation, all because someone didn't understand how to service and maintain their air conditioning system. So there's quite some few challenges, particular challenges about different components on the vehicles. And finally, we need something to drive the vehicle, a big motor. When I say a big motor, actually, it's not much significantly bigger than a combustion engine, okay? But it's quite powerful. It needs to be. So we're talking, for an average car, say 35, 45 kilowatt motors. If we're talking more performance, then we're up into the 100 kilowatt motors and stuff like this. And this gives us an idea. And they're all 3-phase. Most of them are brushless, predominantly, most of them are brushless, and they're what you call synchronous motors. So what we mean by is this machine here, this inverter understands the position of this, and then it can commutate the phases very accurately. It does that in real time. Okay, so we synchronize the position of that magnetic rotor, okay, a strong magnetic rotor, to exactly how we commutate those three phases, and it works much more efficiently there. If we look at an electric motor in the workshop, that's what we call unsynchronous. So we use the national grid to just spin the motor around. It doesn't matter where the position is, but we're quite crucial about where these positions are. So we use what we call a resolver sensor. Anybody heard of a resolver sensor? Anybody? Crankshaft position sensor, maybe, yeah. That's quite simple, fairly easy, but that's not good enough. We need something a bit more live data, put it that way. So whatever vehicle I work on, or whatever vehicle we talk about, whether it's a hybrid, whether it's a plug-in hybrid, whether it's a range extender or a full electric vehicle, pretty much you're going to have all these components on the vehicle. And they can be challenging sometimes. If any one of these things doesn't work properly, you're probably going to have a non-start vehicle, okay? Or restricted performance, certainly. And then you need a different skill set to understand how to diagnose and maintain, how to diagnose, troubleshoot, and particularly repair that type of component, certainly. All right. What's the alternative to electric vehicles, guys? What's the next step? What's the future?
Yeah, that's the question. yeah, that's a big question.
Yeah. What do you think it will be?
It will be still a generator, for sure. And different power sources, maybe.
Different sort of energy generation.
Yeah.
Now, some people would argue we won't have the electric vehicle in the future. We'll have some alternatives. And certainly people are talking about hydrogen fuel cell technology. And that's been around for a long time. How long? Where was the first commercial application of a fuel cell? Sorry? Where? No. No. Way before that. Way before that. Some of you weren't when you were born then. Sorry.
Is it in the same era, around the 1900s?
No. No, you're going too far now. Back off a little bit. Come this way, isn't it?
Didn't they make some test around with the heavy industry engines, hydrogen?
No. Look up to the stars. Might give you.
Space.
Yes.
Okay.
In the 1950s and 60s, what do we want to do? What do the Americans want to do?
Drive on the moon.
We want to go to the moon. Where are you going to get power from when you're like hundreds of thousands of miles away from Mother Earth? The only efficient way of doing that was to use hydrogen and develop something that can produce electrical energy. And the byproduct of that is water. So a fuel cell was actually a good solution for that sort of type of environment. So that from the 1960s, way before we developed the modern electrical powertrain system, was developed. So why didn't we go that way? Because it's too expensive, very expensive to develop and produce. It's getting more popular, but of course then we create more kind of problems as far as hydrogen fuel cells are concerned. Because we need an infrastructure to develop or produce hydrogen, we need to distribute that hydrogen, we need to store it, and what sort of pressures do we need required for that hydrogen to be to use in a fuel cell technology?
In a car, it's up to 700 bars.
Yeah, 700 bars. That's a lot of pounds per square inch, isn't it? That gets really dangerous. Yeah, and no one can agree on what that pressure should be. I went to Germany once and they had a fuel station there with 3 different pressures. There's a 300, I think there's a 500 and a 700 bar pressures. So no one can agree on it. It is suitable for long distances. So I would imagine that we would see hydrogen fuel cells being developed for heavy goods vehicles, for public service vehicles like buses, coaches and stuff like this, because we can do long distances on this, but it gets expensive. And buses and heavy goods vehicles are commercial vehicles. It's a bit like an aircraft. It doesn't make money unless it's in the sky, and particularly with passengers in it or cargo and stuff like that. You need something to pay for that. And commercial vehicles and public service vehicles do that. So there is a numbers game to be had from fuel cell technology. But the problem with, it's not the problem, but at the end of the day, a fuel cell produces electrical energy. So we need a battery to store it in. We need a PTC heater. We need an inverter converter. We need an AC compressor, and we need an electric motor, and so forth and so forth. So the vehicle is still electrical. We've just added to the complication of that. For heavy goods, for large vehicles, I get it. It makes a good alternative to that. And perhaps we will see that in our future. But for the light passenger, personal vehicle transportation solution, the electric, now we seem to see batteries that are getting it more efficient, giving us better range. It for most people is going to be where we're going to remain for the foreseeable future. Unless you can harness nuclear fusion. If you could do that, then
You can use thorium.
yeah, you can have, that'll be your energy supply for the rest of your life in probably a small test tube, but
They are
yeah.
working on it.
Sorry?
They are working on it.
Yeah, everyone's working on it, don't worry. But there you go. Has anybody watched that Oppenheimer movie? You seen the Oppenheimer movie? Yeah, interesting. Okay, fine. So what are the dangers and risks of work on these types of vehicles? We've got, the obvious one's electrocution, isn't it, guys? Yeah. Don't muck about with this stuff. Seriously, it's life and death kind of stuff here. You don't get a second chance. Because it's direct current, it's far more. Who's been electrocuted, by the way? Who's managed to electrocute themselves? Anybody done that? Yeah, there's a few. It's not pleasant, is it? And we don't do it on purpose. Well, there is some people I do know that try it. And do you deal with insulation testers? Do you do insulation testing? No. Insulation it basically produces up to 1,000 volts, and it will give you a nice, it's a bit like a cattle prod, you know, so if you move cows and sheep and stuff like that, they're good for that. Or motivational tools, if your student isn't working so hard, you can, that sort of thing. No, I joke, but anyway. But when we're dealing with DC, it is, you know, it's direct current. It's really serious. When we look with AC, so what frequency do you use on your national grid? Is it 50 or 60 hertz?
50.
50. Here's a question for you. Why is it 50? Everybody does that, I don't know. But there's got to be a reason for it. We didn't just go, I'll tell you what, let's go down the pub and we'll decide. Let's say 50's fine. We don't, well, I hope we didn't do that. There must be a technical reason for it, surely. Anybody pondered late at night after you've had a couple of beers going, why is it 50 hertz? Any reason?
If it was 10, you would see it.
We got some.
Isn't that so?
We got some. I'll show you. We got some.
Yeah, just keep them occupied and I'll get you.
Oh, okay, thank you. Yeah, that's right. It's an interesting question, and this gives you an idea of why AC is I wouldn't say safe. It's safer than DC. But most countries, well, you're 50, UK's 50. Some other countries are 60 hertz, aren't they? What is your? Is it 110, 120?
220, 40.
Two. Okay, fine. All right. And there's a good reason behind that. I'll come back once you get some. I'll do some drawings for you in a second. Okay. So we need to be careful about electrocution on these types of vehicles, and we need to be aware of when the system is live. When is that battery switched on? When is it switched off? When is it discharged? There's some very big capacitors in these vehicle systems. Usually in the inverter converter, I mean big ones, okay? And they can retain a state of charge for some significant time. Thanks.
Not sure if...
No, that's all right, that'll do. Can you see this? I'm going outside my marker now. I've been told to stay inside here. Let me get this over here. So if I was going to draw AC, an AC, give me a, that's a bit better. An AC looks like this, doesn't it, yeah? Yeah, it alternates between positive and negative. Would you agree with that, yeah? Okay, and let's say it's 50 hertz. So 50 times a second, these lights are switching on and off. You can't see it because it's too fast, okay? So let's say we say this is at 220, and this is at 220. So this is the maximum potential difference in the voltage supply. That's what overcomes your resistance. That's when current passes through your body, okay? And you feel it. Now, when you get electrocuted, not on purpose, obviously, but you stick your fingers in, or it's normally the light socket, isn't it? Because it's always live, most of the case. Well, it is in the UK. Even if you switch it off, it's still live. Stick your finger in there and you'll get an idea, okay? The thing is when we feel it, our threshold for electrocution, maybe around about here. So this is the point at which we get electrocuted, okay? This is the time we get electrocuted, okay? Anything below that, our resistance is too high. We don't feel it. Go back to your car on the way home tonight or whatever it is and say, open the bonnet, lick your thumbs, stick them on that 12-volt battery. Do you get electrocuted? No. There is not enough potential difference. It doesn't. Even 24 volts. Nope, nothing there. So we need to increase the voltage. That overcomes our resistance. When we do that, we get electrocuted, but only for a period of time. Now, I know it's going to be 50 times a second. And if you do experience it, you get that kind of, you know, your muscles are contracting and extending, okay? So when we go below this, so if I draw a line here and draw a line here, this is the time you don't get electrocuted. That's when you let go. So a domestic supply, a normal domestic supply, you can let go, most people. Obviously, if you've got some sort of physical impairment, a heart that's a bit weak and stuff like this, it can be fatal, or it can have some serious consequences. But that's why we have it at 50 hertz. If I did it faster, you get less time. Okay? If I did it for longer, or if the frequency was lower, I electrocute you for longer. So that's why we choose a particular frequency to supply our national grid. Does that make sense, guys? Gives you a brief idea. Okay, cool. So electrocution, when we talk about DC, the DC is constant. You can't let go, guys. Okay? So that's the difference. That's why it's far more risky to work with DC than it is AC. All right, guys? Cool. Excellent stuff. Right, what other risks do we have? Now I've frightened you a little bit. Got risk of fire and explosion. This gentleman over here understands what happens to a battery if we overcharge it, undercharge it, give it too much current and stuff like this. The environment's not suitable, or it goes just exothermic on us anyway. We get a huge amount of discharge of energy. A lot of heat. Most lithium-ion batteries will produce their own oxygen, so it fuels itself. That's why lithium batteries are so difficult to extinguish. Okay, and if you've got a large battery like on a vehicle, that's going to take some time. So fire and explosion is another risk. Got some chemical risks, certainly with nickel metal hydride batteries and some lithium-ion batteries, a bit like lead-acid batteries. There's some chemicals in there that are not very nice to us, and or the environment either. Okay. And then we've got some other magnetic risks. Our motors are built with what we call neodymium rare earth magnets. Very, very strong magnets. Can affect medical implants, electrical devices and so forth. So close handling of electric motor, you need to make sure that you're not going to be affected by, I have on occasions, these things. So I've gone back to my hotel room because I've been working on electric motor and I can't get into my room because it's damaged out. If you don't like someone, then just put their mobile phone on electric motor and the phone will never work again. But I'm not saying that you should do that. And finally, we do have some mechanical risks. More importantly, electric motors do not make a noise, guys. Not as much as a combustion engine. So please be aware when the system is live, because there can be some mechanical risks there as well, particularly hybrids, plug-in hybrids and range extenders. Okay. So our conventional set of skills we involved as far as the automotive industry is we see it, we hear it, we feel it sometimes, and probably smell it. So if I brought a car into a vehicle, into a garage, and I asked them to diagnose a problem, the technician will probably do some testing, he'll look around it, he'll probably feel it, drive it, might smell something that's not right, or whatever, and he can diagnose that, she can diagnose that problem, pretty much, or lead along the right path to get to solve the problem. But when we talk about new skills for electrical, we don't see it. You don't want to feel it, do you? Okay? You can't hear it sometimes, pretty much most of the time, and we only smell it when it's too late. So we need another set of skills. What sort of skills do we require to work on these types of vehicles, guys? We need really strong electrical skills, really confident electrical skills, really good diagnostic skills. And of course, we need to make sure that we understand the risks when working on these types of vehicles. So there is a different set of skill sets for these, to make sure that not only are you safe, your colleagues are safe, but also you don't damage the vehicle and you correctly diagnose the type of vehicle you're working on. It can get really expensive if you misdiagnose these types of vehicles. So what we've developed over time as a company is a set of qualifications. We've worked with the National Occupational Standards in the UK, and we have a set of qualifications that allow technicians, individuals, to get educated, understand the risks, and get equipped to make sure they work on these types. Give them the confidence to work on these types of vehicles, because they're coming anyway, guys. Transition to EV, you probably know some of this. The infrastructure, a lot of people argue about infrastructure. And I say, well, there is the infrastructure. Every household has electricity in it, isn't it? All you've got to do is connect it to the car or the vehicle. It's not a problem. That's a much easier thing to solve than, say, hydrogen infrastructure, certainly. Range, we're getting over that because battery performance is getting better and better as we talk. Reliability in battery, that's an interesting one. Early batteries are not as reliable as later batteries, perhaps. And certainly diagnosis of batteries or predicting early battery failure is an important factor as well. So there's quite a lot of challenges there. The skills in the industry to meet demand. I'd say demand is outstripping the skills in the industry at the moment. There's a lot of people that I come across go to garages and won't even touch an electric vehicle at this stage, even in the UK. So there's opportunities there for the industry, certainly. Some troubleshooting skills to repair. And of course, one of the challenges, probably not quite as evident as it is the parts to repair. Because there isn't the parts infrastructure to supply repairs to electric vehicles as yet. Manufacturers are too busy building them. They haven't got spares. Ask Tesla, anybody. Quite often, biggest problem with Tesla customers is they can't get the parts for their cars. So whether it's an electrical part or not, Tesla have a problem with parts availability. Well, yes, but they're not a motor manufacturer. They're a technology company. They don't understand, but they're learning. They don't understand the challenges and the infrastructure required to get to the level of manufacturers that are already established. But I'm sure they'll get there at some stage. But we'll see. We'll see. Maybe Mr. Musk is not bothered, I don't know. Once he sells you the car, that's it. And some people argue, is there enough electrical energy? That's an interesting one. People say, well, there's not the infrastructure, there's not the power in the country to charge all the vehicles up. What I say is actually the car is the solution, not the problem. The one thing we don't do in any country is we store any significant amount of energy. We only produce it for what we require, no more, no less. If you imagine, say in the UK, we had sort of like 20 million electric vehicles plugged in, we'd have enough storage to power the country. So we don't need as many power stations. So the electric vehicle actually is going to provide more solutions and be more significant in society than the combustion engine vehicle was ever going to be. Let's face it, hands up, how much percentage of the day do you use your car for? 10%? Wait, exactly. Most people, it's probably 5, maybe less. But you've got a big battery there sitting there doing nothing. So, but if it's connected to the grid, now we've got storage, which makes a lot more sense. You have national security as well. The one thing, and I don't want to get into politics, the one thing that Putin's trying to do is disrupt the infrastructure. And that's quite vulnerable because you'll have cables between power stations and cities. But if we can locally supply, locally support with power that's stored locally, then that's a much better solution, a more survivable solution than we've ever had before. So if you've any doubt electric vehicles are coming to society, then these are going to provide a lot more solutions than you may think. And being in the industry now is a good place to be, because you'll be at the forefront of all of that and establish yourself as being the experts in electric vehicle technology. Okay, cool. Right, quick, have I got enough time?
Yes, just checked. We can be past 12, so no worries. Plenty of time.
I'm always conscious that I'd overrun a little bit. I wanted to share with you, because I was just thinking the other day, so I want to give you an example of what the challenges are. And here's a challenge. Some time ago, we had a delegate with us who worked at a Porsche specialist, not an official Porsche dealer, but a well-established Porsche specialist in London. And he rang me up and he said, Eliot, I should know what I'm doing, but I've got a Porsche Cayenne hybrid that doesn't start. And I said, okay, what have you done? I said, I've taken the battery out. I said, why have you taken the battery out? And he said, because there was water in the boot. I said, okay, fine. Did you get the fault codes out of it? And he went, no. I went, well, it's not the best thing to do. He said, can I bring the battery in to you to have a look and check it over? Because I think that's the problem. I said, okay, I don't really usually do this sort of thing, but on this occasion, because he was a young guy, wanted to learn, I thought we'd support him and give him some things. This is the battery voltages, or the cell voltages in this battery, okay? And you can see I've blocked them, so from block A, okay, and block B. So they're divided into two sections, and there's one battery or module that straps over across the two of them. But essentially, there are four individual voltages being monitored by the battery monitoring system. So there's quite a significant monitoring of this battery. Is there anything significant that you can see that is different about those numbers? Yeah?
Yeah, one is a lot lower.
This one, yeah. If you look here, you can see this one, 4.12 volts. Okay, I'm not saying that's the problem, why the vehicle wouldn't start. There's another problem. But this led to the problem that's going to happen. So if we look at this 4.12 voltage, everything's around about 5.3. Yeah, it's about 5 pretty stable, and that's the balance within the battery. So when we go back to physics, when we look at Ohm's law, resistance and current and voltage influence each other. If I have a low voltage here, that might imply that I've got a degrading battery within, or degrading cell within the battery, which usually means higher resistance. If there's higher resistance, when I put current through it, it creates heat, which is difficult to manage. If I create heat, then I get close to maybe an exothermic reaction within the battery cell. So that battery management system decided not to allow that battery to switch on. It was protecting the battery from further damage to the whole of the vehicle in this case. But it's not the problem, okay? So what we did is we checked all the voltages, stripped the battery down, got access to all the individual cells, did a spreadsheet like we have here. This is the spreadsheet we assembled, and you can see we've got a problem here. So what do? We recharged that individual cell. Okay, you can see the module voltage is also significantly different from the other ones. When we recharged it, we got it to somewhere closer to where it should be. Okay, hopefully now the battery management system will start because there's significant balance within that battery to allow it to continue to work as far as the vehicle system is concerned. Remember, if you haven't got high voltage, you haven't got anything. You can't charge a 12-volt system, you can't do anything, you can't drive the vehicle or whatever. So if we look at, now we've got some reasonable voltage within the cells and a balance. So pre-battery block balance, when we checked, it was 1.32, and now we're down to 0.03 in some cases. I know it doesn't correlate exactly with what it is, but this is a spreadsheet we put together. So we were happy that if we start the vehicle, put the battery back in the vehicle, it should start. Okay, so the guy took the battery back to the dealership, put it in there. I said, ring me tomorrow, tell me what happened. So he put the battery back in the car, hit the start button, and the car started. And I said, right, what are the fault codes in the system? And he said, breach of insulation. Because the water got inside the battery, what it did was it discharged one cell because it partially short-circuited that one cell, significantly enough to discharge it below the threshold allowable in the battery. Okay? So the battery was fine, the cell was fine, it's in perfect working order, it just managed to go out of balance. Okay? Had a breach of insulation, that's why it wouldn't start, because it suggests there is a breach of insulation between the high voltage system and the low voltage system. And it's constantly monitored. Okay? Once that's established, cleared the fault codes, the battery's fine. Now, when I spoke to the guy, he said to me the client went to a Porsche dealer. And the Porsche dealer quoted them £6,000 for a new battery. And he charged them, or was going to charge them £6,500 for the labour. So it's a £12,500 repair. And actually, all it is a labour cost. I don't know what he charged him, but it was significantly less. So you can see, with knowledge and skills, the right equipment, understanding how to troubleshoot things like this, can actually serve your clients really, really well. Provide a good solution to maybe even a franchise dealer solution in some cases. And what we're finding in the UK is actually independent dealers are better than franchise dealers, because the franchise dealers are not being trained as adequately from the manufacturer as the independents are. So yeah, there's an industry to be had there. Does that make sense, guys?
Yeah, it does. Of course it does, but the battery system, you could use your diagnosis tool to basically make them even again. Just, and that's they should have tried it first.
We can do it by software to try to recover it again, but it's normally a problem in itself. We cannot to adjust it. We can take the cell out and adjust it and try it again. We had the same solution after some days or weeks.
Yeah, this is a 20-year-old.
Yeah, if it's, no, I agree, and that's the difference. Understanding whether a battery imbalance is a charge problem or is it a state of health problem. A state of health problem is more challenging because you need to find a cell of this.
That's really easy today because we have every counted and we have this grid and we can take every cell out. And
yes.
No problem.
But
we have these measurements already on the screen. So
okay, sure. Yeah, you can identify the problem, but the problem is, in some cases, if it's a state of charge problem, that's an easy solution because you recharge that section of the battery to where it should be. If it's a state of health because an individual cell or block has degraded quicker, that's a more difficult solution because you need to replace that cell or that block with the same state of health as the rest of the battery.
yeah, you adjust it to the same.
That's the challenge. But there are, in the UK, there are companies coming up with solutions for testing batteries, grading batteries, so they will sell you a graded battery to match your used battery already. So that's producing more economy, more employment within the UK as well. So people are finding opportunities for this. Because car manufacturers, there's two things car manufacturers do, which is kind of paradox, is that they don't want the batteries back. They don't want them.
That depends on the companies.
No, they don't want them back.
Yeah.
Well, only if they have an infrastructure that it doesn't distract them from producing new vehicles.
We have an exchange system for our branch.
You may have, but
That's very easy enough.
but if you go to the manufacturer, because we have conversations with them, they don't want the batteries back. They want to sell you the car, produce it, that's it.
They want to sell it.
Yes.
Now they have to take care of that.
They do, but they'll have an infrastructure that is contracted separate from production. They don't want the cost. Okay? And manufacturers are very wary of what the future holds as far as battery reliability is concerned, because you can't just dig a hole and get rid of batteries. What are you going to do with them? You need to repurpose them, recycle them, or refurbish them and stuff like that. But you need an infrastructure to do that. Yeah. And in the UK, it's interesting because in the UK we don't have that yet because there isn't enough batteries to make it profitable.
But it's offered for it.
But as time goes by, things will improve. And this is what I'm saying is here's the opportunity for industries, companies to provide solutions. Get the solution before it becomes the problem. A turnkey solution that is happening already. So I know some clients that have worked with us and established themselves in the market for what I call sort of recycled or green batteries to help independents repair those batteries if it's a state of health problem. Or even take the battery away from them, provide a solution, say, we'll give you a refurbished battery, we'll give you a warranty for it, say, for the next 2 years. That's an easy solution for a garage or an automotive facility, certainly. But yeah, let's just give you some example, the challenges at least anyway. Okay. So how will it impact our lives? Like I've said, we need some qualifications. In the UK, we've got some nice qualifications. I could share that information with you a bit later on. I've got a slide to show you that. And we have qualifications that are designed specifically for different types of disciplines, whether you're a fire crew, an ambulance driver, a policeman, you're a designer, you're a technician, you're producing or manufacturing batteries and stuff like this. So there's different levels of qualifications available in the industry. And of course, there's specialist equipment. Of course, there's the PPE we need to worry about because we want to keep you guys safe. And there's, of course, obviously some specialist equipment like insulation testers, equipotential bonding that we need to check every time we change a component, air conditioning systems. You need to use a different refrigerant and stuff, refrigerant oil and stuff. So you need to be aware of the challenges and equip those garages to make sure that they're doing the job properly. So the experience of the consumer is a good one. We don't want a consumer to come to a garage or come to the industry and find out we're struggling with a solution for it. That doesn't look good.
The AC tubes on the market today,
Yes.
are they capable of having this oil?
Yes. So the big,
If you look at the latest one now, not just only for EV, also for a normal combustion engine AC car, are they using the same?
So a lot of body repair shops, because they see a lot of air conditioning problems because obviously it's the condenser that gets damaged. So you lose the refrigerant and you have to recharge it. And a lot of body shops say, well, we don't want two machines, one for combustion engines, one for... Right. So we use the same oil for the combustion engine as we do for the electric vehicle because the combustion oil is not a problem. It is compatible. So don't use two oils, use one for everything. That's the solution. But some garages were buying two machines and two different oils.
So with 134 and...
1234, yeah. Yeah. The refrigerant is not important, it's the oil. So you have a PAG oil for combustion engines and you have a POE for electric vehicles. Use the POE for everything. Yeah. Then there's no cross-contamination between the two. Is that okay? Yeah. That's the easiest solution, if I'm honest. So little things like that give a solution to a garage that might be looking at buying two machines or whatever it is. And of course, if you use PAG oil on a vehicle that should be with POE, then eventually, and we've seen it, you'll get a breach of insulation. Yeah. And then the car won't start. And then you need to flush the system out, clean it, whatever it is, refresh it, all because someone didn't use the right oil when they serviced the air conditioning system. And if I'm honest, air conditioning systems are more demanding on electric vehicles because we need to use the refrigerant and sometimes hot gas to increase cabin temperature. We use the refrigerant when it's hot to warm the cabin up, and quite often we need to, well, not in this country obviously because you don't get that hot, but in some hotter countries where the air conditioning system is critical to maintain the battery temperature so it doesn't get too hot, so it works harder. So,
actually, we are using the AC system during the whole year.
well, yeah.
We need to take the humidity out.
Correct. That's what most people don't realise about air conditioning is it takes the moisture out of the atmosphere. But yeah, for hotter countries, we need to. The battery temperature gets too hot, and with the air conditioning, is designed to extract the heat from the battery to make sure it's happier. Certainly, and I would suggest to most independent garages where we never really kind of have a service schedule for air conditioning servicing. We say. It's when the customer goes, oh, it's not working. Like my wife the other way, oh, my air conditioner not working because it's getting warmer. And she realises it's not working as well. So every 2 or 3 years we recharge it. But I'm suggesting when it goes in for a service, we do a performance test on the air conditioning system to ensure you don't get to that point where the air conditioning system's struggling to...
It's more important for EV.
Yes.
So,
and the heating system as well.
yeah, so you actually are recommending that in the annual service or 2-year service, it will be always checked.
Annual service.
Yeah.
Check the air conditioning. It's preventative maintenance rather than corrective maintenance. But
We have no problem with that.
yeah,
2 years.
but that produces another challenge: is to educate the consumer to say, look, we're going to service. There will be a charge for it, but we're going to service it because it's preventative rather than corrective maintenance. And that's why I would suggest to most independent
It's not
dealers.
on the checklist from the manufacturer.
No. Well, the other thing the manufacturer never asked us to do is change the filter, the dryer on the air conditioning system. In my personal opinion, should be changed every 2 or 3 years because it gets too much moisture in it. And that's what damages the air conditioning system.
Is that glove from woodworking? Or?
The glove, no, it's from the electrical industry. Oh, yeah. It's on, you know guys that are carpenters, yeah, they've always got one digit missing, so.
I want 5 beers.
Yeah. Sorry, yes. Oh, I've gone too far. So things like insulation tools, insulation testers, the proper correct PPE and stuff like this, as long as you equip yourself. And yeah, diagnostic tools are essential now because, like I say, you can't hear it, you can't see it, you maybe smell it, but you don't want to feel it. So, so you've got a different set of skills that most mechanics or most technicians have relied on for many years that we need to change a little bit. So, and it's a massive change. It's the biggest change we've seen in the automotive industry in 100 years. It's where we were 100 years ago, pretty much, and we've gone completely back the other way. And we haven't got those skill sets in the industry. But the people that equip themselves and skill themselves will definitely have an advantage in the future. All right, guys. Just quickly, if you want, I've got some handouts. This is the one I'll let hand out. This explains or gives you some idea of the qualifications that we've developed and put together in the UK industry, of which Sig was, you know about all the qualifications that we do and stuff like this.
We have the IME, same as you.
Okay.
We're also IME certified.
Okay.
Then just to add on that, and what at least 2 of the guys here did last week with Rob, is that
Sorry.
we actually brought Rob from Promoto last week to have a course on diagnostics.
Sure.
And I think there's going to be probably more of that. So that's kind of add on to the IMI. So what Promoto and Eliot have developed as a add on to the otherwise certified courses.
So are you going to develop your own national qualification?
No, there's nothing.
Okay.
So we are using the IMI to, like we're talking about the certifications, in order to have some kind of certification in this.
Right.
So that's
So
why
you're-
we reached out to IMI.
So you're going to become an IMI approved centre?
We are.
Okay, you are. Okay, fine.
Yeah,
Yeah,
since
cool.
2020.
Well, if you tell the guys that you got trained by us, then they'll go fine.
Yeah,
No
but
problem.
I'm thinking that the addition that you have, so the battery analysis and the
Yeah.
problem solving and the charging, that's something that I think we could
Okay.
continue like we did.
Sure. Okay, fine. No worries.
So Rob will probably hopefully come back.
He loves travelling. Listen, thanks for listening. Hopefully it gives you some idea. Is there any questions? Please ask. Any challenges, anything you've come across, or anything that you've got any doubts about, want some advice about? You could talk to me afterwards if you wish. It's not a problem. But if you've got any questions, please ask. Yes.
You mentioned about the manufacturer didn't want the battery back.
Yes.
Okay. How is the UK market handling replaced batteries that they cannot return back?
They
Do
stop.
you have a infrastructure for that already?
No, there is no infrastructure. They are building a factory for recycling, or what I call reverse supply chain of batteries. And that's going to be something that's going to be offered to manufacturers. Manufacturers don't want batteries. Got nowhere to put them.
Well, at the moment, there's an 8-year warranty on a battery.
Yes.
So, because this revolution is not so old,
Yes.
mostly within warranty period.
Yep.
But we have seen manufacturers, they don't want them back anyway.
No.
We don't know what to do with them.
Yeah, that.
Batteries.
And
We have a solution for get rid of them.
Yeah, not for everybody.
Yeah,
No.
for every factory you can.
Yeah, for some, my knowledge.
There is a market for it in
Yeah,
Holland
we
or-
can ship it abroad, of course.
yes. Yeah. So if you go to sort of Central Europe, there are solutions there because there are more batteries. So the financially it makes sense to build facilities that can cope with the return of batteries. Manufacturers, when I say they don't want, as far as the consumer is concerned, yes, there is a warranty on it, and if there's a problem with it, it goes back to the manufacturer. It doesn't go back to them. What are they going to do with it? They've got no facilities, no skill sets to refurbish or check the battery. They'll contract it out. For example, we had DHL come to us and say, we want to offer a reverse supply chain solution to manufacturers because we can do the pickup. We can just transporting lithium-ion batteries is a headache to start with. It's category 9 dangerous goods, and you need all the certification and stuff like this. So, what better solution is that someone who ships that and will charge you for shipping a category 9 is the actual people that come up with a solution because they can ship and transport those around. All they need is skilling and the facilities to refurbish it. So in the UK, there is no facility as yet, but there will be in the next 2 or 3 years. Because again, as I said, there isn't enough numbers to make it financially viable yet. But it will happen. Because as the market increases with more electric vehicles, more failures, age of batteries will start to fall off at the other end. So then what do we do with them? Do we use them for storage? Do we use them for other purposes? Or do we have to recycle them and make new batteries? So, but that's the good, in my eye, that's the good solution. Well, that's the good challenge because there is a solution that creates wealth and employment for society. It's just a different skill set. That's all it is. Like, we ship engines. There's a company just down the road from us that ship engines back to India.
Yeah,
For refurbishment and smelting down and stuff like this. But if you can do it locally, that's more environmentally friendly and more efficient. But that's what, my wife hates me going out because whenever someone says, what do you do for a living, Eliot? And she goes, because it turns into a debate about, what are you going to do with the batteries? The batteries haven't got range and that's not the solution and everything else. And there's always an answer to everything. There's always, but it's a challenge. But it's up to us to.
It's also because we have a guy from northern Sweden where we have Northvolt, who's going to speak tomorrow. And that's a battery manufacturer. So they are also building up a recycling plant that they already have. So they are working with Volkswagen, Volvo, Scania. So that's also something that's probably going to, that's the demand or requirements for them that they will take back their batteries. So it's just we're not there yet. That it's because it is quite young industry. So we need to have the mass to make it profitable.
Yeah, you need the numbers to make it.
But of course, I think it's going to be more that actually the manufacturer, because the raw material is expensive, and it's better to get it back
Yeah,
into the cycle.
yep. Once you've dug it out of the ground, just use it again and again and again.
So it's going to be more.
Okay.
Yeah, there are companies in Europe that rebuild the batteries, and also you don't have to buy them; you just lease them.
Yeah, yeah.
So basically, you own a car with a leased battery, and you pay your monthly fee.
Wait, we have a Zoe on one of our cars we use for training is a Zoe, and we sublease the battery.
Yeah.
But recently they've rang us up and said, "Do you want to buy it off us?" Because Renault don't want the battery because they know that it will fail at some point, and they haven't got a solution to deal with the failure or return of those batteries. I know why they leased them, because they wanted to lower the anxiety of purchase from the consumer. Oh, don't worry about it, it's leased, so that if it fails, we'll give you a new one. But now they're realising that's probably not the model of solution for the market now. So yeah, but it's interesting times, very interesting. Challenging, but also some opportunities as well, massive opportunities.